Okay, in this video we'll check out some uses of the sum and difference identities, keeping it a bit basic, how to find some exact values of trig functions of angles that maybe are not on the unit circle, or I mean they definitely are not, otherwise we would just use the unit circle for the special angles. And then the third example we'll just have one with tangent, in which we'll simplify, but it has an x in there. So first let's look at these formulas. Sometimes they're written as 6 different formulas, sometimes they just use 3. I prefer the 3. That way you understand what this notation represents anyway. So notice cosine alpha plus minus beta. On the right hand side, cosine alpha, cosine beta minus plus sine alpha, sine beta. That means if I have alpha plus beta for cosine, I'm going to use the minus on the right side. Or if I have the minus, I'll use the plus. Okay, they're opposite. But look at the sine alpha plus minus beta. The sign on the right is also plus minus. Tangent is, I guess, a bit more complex than the other two formulas. And notice in the numerator we have plus minus, but in the denominator minus plus. Okay, let's do an example of each, sine, cosine, and tangent. I am actually going to do sine first because it's in degrees and we can typically think of our degrees a bit easier, so it'll be easier to demonstrate what we're doing in this example. First, I want to point out 75 is less than 90, right? So if we're thinking quadrants, we're in quadrant 1, which all trig functions are positive in quadrant 1. So therefore, our result should be positive. Now, why would we do any of this? Like, I could just use a calculator and get an approximate answer. That's true. But you can't use a calculator in this third one over here, right? There's an x. So it does have its purposes, and we will need these formulas in more advanced math classes, right? Often we're building upon principles that we would use later on. So let's move forward. I can think of 75 as 45 degrees plus 30 degrees. Why did I choose those two? Because they're both special angles that are on the unit circle. I know the values for all the trig functions of 30 and 45 degrees. Okay, that's why I chose that. Now looking at the formula, sine alpha plus, right, beta, so therefore this alpha plus beta. Anywhere we see an alpha, we'll put 45. Anywhere we see a beta, we'll put 30. So this is equivalent to sine 45 cosine 30 plus cosine 45 sine 30. All of those are special values, so we have root 2 over 2. Cosine of 30 is root 3 over 2. Plus 45 is root 2 over 2. And 30, cosine of 30 is sine of 30 is 1/2. And multiplying, we get root 6 over 4 plus root 2 over 4. They have an LCD, so might as well combine them. Root 6 plus root 2 all over 4, which is not root 8 over 4, right? We cannot do anything more to that. Now, as you're getting used to these, I recommend the ones you could use a calculator to make sure. Plug this expression in the calculator, get a decimal approximation, plug your original sine 75, make sure that decimal approximation is equivalent to the result you got. All right, next one, 7 pi over 12. What two angles sum to be 7 pi over 12? That's a little more challenging. So a couple options. One, you could convert to degrees and then back to radians, and interchange between the two as needed. In this one, technically, you could just stick with degrees. I'm going to show another way, though, is 7 pi over 12. So we know all of our values are like pi over 6, pi over 4, pi over 3, right? Things like that. So one way to do it is think, well, 7 pi could be like 4 pi plus 3 pi, right? That would be 7 pi over 12. It could be 6 pi plus 1 pi, but the thing is I'm trying to look for things on the unit circle. Pi over 12 is not on the unit circle. Now 4 pi over 12 isn't on the unit circle the way it's written, but this is equivalent to pi over 3, right? And this is equivalent to pi over 4. So both of those are on the unit circle. And again, you could have went to degrees. This actually would have been 105, I believe. And there's a 60 and a 45. Now, I typically stick to plus, but you don't have to. Sometimes you have to do minus. Like, I don't know, say I wanted sine of 15 degrees. Right, really quick side tangent. Sine of 15 degrees. Now I'd have to do minus, right? Maybe like sine of 60 minus 45. Or 45 minus 30, right? There are many options. Point is, you don't have to stick, like, there's more than one approach at doing many of these. All right, we have two values that are special angles on the unit circle. We can proceed. We have cosine. This is alpha, this is beta. And remember, with the plus for cosine, we actually have to use the minus of the right-hand side. So we get cosine alpha, cosine pi over 3, times cosine beta, pi over 4, minus sine alpha, sine pi over 3, times sine pi over 4. Also note, we're in quadrant 2, right? 7 pi over 12 is slightly bigger than 1/2, which is pi over 2. It's somewhere right here. So cosine should be negative. All students take calculus. Cosine should be negative. Cosine of pi over 3, so that we get 1/2 times root 2 over 2 minus sine of pi over 3 is root 3 over 2 times root 2 over 2. So we get root 2 over 4 minus root 6 over 4. And we could combine, since we have an LCD, which would definitely be negative, right? Square root of 2 minus square root of 6 is a negative. And again, I would recommend just plugging that in the calculator really quick, see what you get for the decimal answer, plug this in the calculator, see what you get, and make sure they are the same. Alrighty. Last example. Tangent x minus pi over 4. So wherever we see an x is going to be alpha. Wherever we see a beta, right, we'll put pi over 4. And it's minus, so we have to follow that formula correctly. I'm going to just switch to green so it separates from the left and right a bit better. So we get tan alpha. So we get tan x. Now the minus goes with the minus on the numerator. Minus tan pi over 4. Over. Now the minus goes with the plus in the denominator, right? The denominator changes signs. Tan alpha, tan x times tan pi over 4. Now tangent of pi over 4 is 1. It's a 45-degree angle, and tangent is y over x, and since the x and y are the same, we get 1. So I can reduce this to tan x minus 1 over 1 plus tan x.